Rahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Two 1 kilogram masses are separated by a spring of negligible mass. Okay, mass of spring is negligible. They are pushed together. Okay, dear students, there are two possibilities whether spring can be compressed so that distance between masses decreases, or spring can be pulled so that distance between masses increases. Okay, so the two possibilities. They are pushed together, compressing the spring. If the work done in compressing the spring is 10 joule, find the change in mass of the system in kilograms. Does the mass increase or decrease? We move to solution of the problem. Okay, dear students, this is a snapshot which has been chosen from some book. I think I am not sure. I think this snapshot has been chosen from the book general physics book written by the same author, almost Paul A. Tipler, 6th edition perhaps, Gianni Mosca. Okay, in addition to Gianni Mosca, perhaps its author is okay. Anyhow, this is not very much relevant. Okay, this is an additional information. Okay, Gianni Mosca, physics for scientists and engineers. Okay, our solution of this problem will be based on the philosophy conveyed by this snapshot. Okay, according to this snapshot, a particle with mass m has an intrinsic rest energy E given by E equal to mc square, where c is equal to 3 into 10 raised to the power 8 meter per second is the speed of light in a vacuum. A system with mass capital M also has a rest energy capital M equal to capital MC square. If a system gains or losses internal energy delta E, it simultaneously gains or losses mass delta M, where delta M is equal to delta E over C square. So dear students, here is this answer to that part of the problem which says that whether mass will increase or decrease. Okay, so our philosophy which we are following in order to solve this problem says that if a system gains or losses internal energy delta E, it simultaneously gains or losses mass delta M. Okay, if system gains or losses internal energy delta E, it simultaneously gains or losses mass delta M, where delta M is equal to delta E over C square. Okay, now we move to next part of this problem. Yes students, this philosophy has also been selected from the same book Modern Physics by Paul A. Tipler. Okay, in the book Modern Physics by Paul A. Tipler, an example is given which relates to similar situation in which there is a spring in between two masses. Okay, from that example I have taken this snapshot, this wording which will help us in solving this problem. Okay, we know that the change in the rest mass of a system of two particles and spring in a totally inelastic collision is given by delta m is equal to ek over c square, where m is the mass of each particle, so that the total mass of the system is 2m. Okay, clearly when small m is the mass of one particle, then 2m is the mass of two particles. When the particles are at rest and far apart, and capital M is the rest mass of the system when it has internal energy Ek. Okay, so this is just a guideline. Okay, now using this expression that delta E is equal to delta MC square, we have, if we keep delta M on one side, then it will become delta E over C square. Delta is given as 10 joule. Okay, while C, sometimes we take the value of C as 3.0 into 10 raised to the power 8 meter per second. Sometimes we take it value as 2.998. Okay, it does not make any difference or very much difference. Okay, so delta M is equal to this over C. This, in place of C we have used its value C square. We know that joule is equal to kilogram meter square per second square. Okay, so in place of joule we have used its alternate units. Now m square, meter square over second square in the numerator will be cancelled with the meter square over second square in the denominator, and we will be left only with the unit kilogram. Okay, and hence our delta m will become equal to 1.11 into 10 raised to the power minus 16 kilogram. Okay, because when we will divide 8.988 by 10, it will become 1.11. Moreover, 10 raised to the power 16 is in the denominator. When it will be shifted to the numerator, it will become minus 16. Okay, so this is the end of our problem. Okay, that is the yes. A little explanation is still remaining. Okay, we have found delta m, which is equal to 1.11 into 10 raised to the power minus 16 kg. Now we come towards remaining part of the problem. Okay, that whether mass increases or decreases. Okay, so in answer to this question, we say that we know that when work is done by the system, the mass decreases, while when work is done on the system, the mass increases. Okay, in view of this philosophy, our answer is hence mass increases by an amount of 1.1 into 10 raised to the power minus 16 kilogram. This is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.